anytime you have a pure element, the oxidation state will always be 0. And if you have an ion, let's say if it's a monoatomic ion, the oxidation state is the same as that ion. Now let's talk about compounds. Whenever you have fluorine inside a compound, when it's not a pure element, fluorine is always going to have a -1 oxidation state. Fluorine is the most electronegative element. When oxygen is in a compound, it's going to have a -2 oxidation state unless it's bonded to fluorine or unless you hear the name peroxide or superoxide. Whenever you hear the name peroxide, oxygen has a -1 oxidation state. If you hear the word superoxide, it has a -1/2 oxidation state. But if you hear the word oxide, then the oxidation state is -2, which is 99% of the time. Now, hydrogen will have an oxidation state of +1 when bonded to a nonmetal. When bonded to a metal, hydrogen will have an oxidation state of -1. And really, the key is electronegativity. Hydrogen is more electronegative than most metals. That's why it bears a negative charge. But hydrogen is usually less electronegative than most nonmetals. And so that's why it bears a positive charge. So typically, the element that's more electronegative is the one that usually carries the negative charge. Now let's work on some examples. What is the oxidation state of magnesium and chlorine in this compound? By the way, most halogens are usually -1. Chlorine typically has a -1 charge, like fluorine. If we write an equation, Mg plus 2Cl, this whole compound is neutral, so therefore the total charge is 0. Now, if chlorine has a -1 oxidation state, that means magnesium has to have a +2 oxidation state. You could literally solve it. And it makes sense. Magnesium is an alkaline earth metal, which typically has a +2 charge. Go ahead and find the oxidation states of aluminum and fluorine in this example. Well, we know that fluorine is -1 in a compound, always. And aluminum, based on where it's located in the periodic table, it's typically +3 within an ionic compound. And you could solve it too. Al plus 3F should add up to 0, because the net charge is 0. So each fluorine atom has an oxidation state of -1. So now we got to add 3 to both sides. So aluminum has an oxidation state of +3. Here's another example. Find the oxidation state of vanadium and oxygen in this compound. So this is called vanadium oxide. So whenever you hear the word oxide, oxygen has a -2 charge. So we got 2 vanadium atoms plus 5 oxygen atoms with a net charge of 0. So each oxygen atom has an oxidation state of -2. 5 times -2 is -10. And then add 10 to both sides, so 2V is equal to 10. Next, divide both sides by 2. So 10 divided by 2 is 5. And so the oxidation state of vanadium is +5.